All right, I'm gonna need people to have their calculators out because we gotta do some SOHCAHTOA for this one. Here I've got this object that's, let's just call it a three-way tug of war, just to make it easy to explain. I'm not gonna put a fancy scenario on it, but three different people decided to have a tug of war, and we gotta figure out a couple of things about it. Find the net force on the object. And then we're going to find the acceleration of the object. And I'll throw this information in here. 4.5 kilogram object. Just so we have the mass in there somewhere. And if we're going to do a vector type problem like this, we really should define for ourselves a reference frame. So I think I'll put it over here. Just kind of tucked out of the way. Let's just make it be a north, south, east, west. And we'll go with the classic. North positive, east positive, south negative, west negative. But I gotta give some values. I'd like to say that force 2, this F2 value, is gonna be 150.0 newtons. Look at all those sig figs. F2 is gonna be, actually let's do F3. F3 is 70.0 newtons. F2 is gonna be 100.0 newtons. And if I'm going to find the net force, it's hard for me. It's 150, 70, and 100. If I'm going to do the net force on this thing, somehow I'm going to have to add up these vectors. Now, net means total. And if I've got a bunch of vectors, I could try and go boink, 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 tip to tail. But that would be a terrible way to do this. It would be hard to keep track of. There's nothing saying it's going to come back on itself to zero it out or anything like that. The best way to deal with this is to do what to each of these vectors? What do you think? X and Y, right? So this is a recurring theme. It's a recurring theme we're going to have to get good at. So I'm going to have, notice that I've got my F2. I'm going to make it as a dotted line so we don't think that we're over-representing things. This is going to be my F2X. I would have to have an F2Y. I'd have to have some information about the angle, so I'll give you that. The angle here, this arc angle here, is 40 degrees. Maybe I'll give you the angle first on this one. This one here is 30 degrees. I'll make it be, let's say that it's 30.0 degrees, just to have three sig figs, but 30 degrees. Just in case you're having a hard time because you're all the way in the back. Make that a little bit bigger, okay? And of course that means that this F3 is going to have a Y component. We'll call it F3Y. And it would have an X component. We can call it F3X. As I look at F1, I'm not going to bother drawing a triangle. Why? Straight X, right? Totally west, if you want to call it that. Okay? So I'm not going to worry about a triangle for that one because I've kind of dealt with components. It's already been handed to us for free. It said in part B of the question that the mass for this thing happened to be 4.50 kilograms. So let's just add that in there as sort of a given. Everything else, though, is my givens. Now, you guys told me that I got to break this down into X and Y components. So I'm going to be organized about this. I'm going to be an XY thinker. So I'm going to make myself like a little X column of information. I'll put a Y column of information over here in just a minute. But F1X is going to be 100 newtons. And as I look at my reference frame, it's not just 100 newtons. What is it? It's west. West is negative. So I'm going to do it in red to draw your attention to the fact that I'm acknowledging that that F1X is to the west, okay? F2X. F2X is going to be F2 times cosine of 40 degrees. Now you can look at your SOHCAHTOA if you like. Cosine of 40 is adjacent over hypotenuse. The hypotenuse is F2. The adjacent is f2x. I've already rearranged it for myself, okay? So f2x is f2 cosine of 40. And I could plug in my values. I've got my f2 150 newtons times cosine of 40 degrees. I need somebody with a calculator for this one. What's 150 cos 40? Yeah. Nice. 0.90, and you said 66? Is it like 66 and then another thing?
It's 6666.
Oh, well, 67, I guess then. Yeah, okay. 67 newtons. Now, if I'm being really careful about this, and I want to be careful because I haven't done these kinds of questions before, force 2x, notice it's east. So if it's to the east, it's not negative. So if I really wanted to emphasize things, that is a positive value. I'm just going to put it in there as a red plus sign just to remind myself that for sure I know that. When I go to do my f2y, sorry, my f3x, I should say, my f3x is going to be f3. Now I got to be a thinker. X isn't always just by default cos, right? Notice that I used cos for a logical reason to get the x component this time, because it was the adjacent. Notice that this time the x is the opposite. So I'm going to use sine. Okay, so I'm going to say f3 sine of 30 degrees. I did that on purpose. I gave the angle with respect to the x-axis the first time and with respect to the y-axis the second time so that I could draw attention to that. Okay? We always have to be thinkers. All right, so f3 sine 30, and I sub in my values. I've got my f3 70 newtons times sine 30 degrees. And again, I need somebody who's quick on the calculator. 70 sine 30. Yep. 35. Yeah, sine 30 is one of those magic angles. It's just a half. Okay, so we should know our magic angles. Sine 30 is a half. Cos 60 is a half. Those are friendly little angles that we should know. And teachers put those on tests and things to help you. But you're right, 35. 35.0 newtons. Now it happens to be to the south, and we called south negative, right? Oh no, what am I saying? I'm on x. It's east. East is positive. Both of these guys are east. Positive. I'm already thinking ahead for my y components. All right, let's give a little bit of division because I'm trying to organize myself a little bit, my x thinking and my y thinking, and there are going to be some people in this room that embrace this organizational way of spreadsheeting out our problems, because I've seen you people when you're doing your projectile problems or whatever, and then there's other people that are still like chaotic and all over the place. What I would say is that there's not like extra marks for being organized like this, but as a pattern of nature, I guess, what I've noticed is that the people that are organized tend to do better. And I won't say that they do better because they're organized, but I would be willing to bet that because they're organized, they're able to think more clearly through a problem. It's not totally causational, but I would bet that being organized and having a clear layout on your page helps you not to get lost. Okay, so I'm throwing it out there. Try to do these problems in an organized manner. Now when I go F1y, notice I'm just thinking about my y information here. That's just 0 newtons, right? There was no y component to that force. We can take a peek at the vector diagram. No y component to that force. F2y is going to be F2 times sine of 40 degrees, 150 newtons times sine 40. Again, somebody with a calculator, help this guy out. It'll be less than 100 and more than 90, I think.
96.4181.
What is it? 96 point?
4181.
Nice. 4181 newtons. And then F3y is going to be F3 times, look, we use sine to get the x component, so we'll use cos to get the y component. But also, if you want to logic it out, we're using cos because we're looking for the adjacent and we're using the hypotenuse. So it's going to be cos. 70.0 newtons times cos 30. And cos 30 is not a magic angle. It doesn't give us a nice 1/2 or something like that. It's kind of an ugly one. What do you get? Oh, it is, yeah. Yep. So 60.621, okay, yeah. Can I just say 622? Whatever. Yeah, 622. As I look at this, is there anything in my y column that should be negative based on our reference frame? Take a look at the picture. Are any of these y values going to be negative? Yep. F3y, you got it. Yeah, so I come back down to my table of values, or my organizer, if you want to call it that, and I recognize, okay, so this guy here, this one was negative. Should have had a negative sign inserted into it. Now the thing is, the math doesn't force the negative sign in, so the thinking agent, you have to force that negative sign in, okay? You're the thinker on this one, you're the problem solver. And what are we trying to do? We're trying to find the net force. Okay, well, I don't have a nice way to spreadsheet this out. So what I'm going to do first is I'm going to deal with the x information. And so this column here is all my x information. And I'm going to say f net x is equal to f1x plus f2x plus f3x. And as I write this out, that means that I have negative 100 newtons. Notice I'm keeping that negative sign. Plus 2x, 114.9067 newtons. Plus 3x, 350 newtons. And somebody with a calculator that can add nicely, what's the net force in the x direction? Now notice, minus 100, plus 100, so it's really 14.9067 plus 35.
49.9067.
What is it? 39? What is it?
49.9067.
49.9067 newtons. All right. So if we're going to find the x component's sum, then we're going to find the y component's sum. So that's our column over here that we're going to pull down. F net y equals f1y plus f2y plus f3y. f1y was 0, so that's nice. But the other ones, we've got f2y and f3y, so 96.4181 newtons minus, because that one's a negative, 60.622 newtons. And again, who's the quickest draw? Phoenix, did you get it already? I saw your face. What'd you get? 35.7961. Nice. And it happens to be positive, just like the previous one happened to be positive. Now for us, those positive forces mean north and east, right? Or, well, I guess east and north respectively. But positive. Both of them are going in the positive direction. So I'm going to take a second just to sketch out what we've got here. And what we've got is an F net x and an F net y that looks like this. F net x, F net y, added tip to tail, which means that we're looking for an F net, which is, by the way, what part A, way back at the top of the page, part A was saying find F net for this system, okay? So we're finding F net, but don't forget F net has a magnitude and it has a direction because it's a vector. I want to take this picture. Now, sadly, I'm going to zoom all the way up to the top of the page. So make sure that you have all this stuff written down, because I'm going to go up to the top of the page. I'm working down a left-hand column of the page, and I'm going to go back up to the top of the right-hand column of the page. And I can zoom out on this after the fact. Don't worry about that. Just remind me. But I want to go all the way back up to the top. I'm going to, well, maybe I'll start off with an arrow and bring my arrow all the way up to the top of the page here. Be an organized problem solver. Put a partition down the middle. This is good modeling for tests or whatever. But then we say, okay, F net is equal to F net x squared plus F net y squared, because we're doing a Pythagorean theorem solution, all square rooted. We sub in our values, 49.9067 newtons, I think is what we said, squared, plus 35.7961 newtons squared, all rooted. And again, somebody who's quick on the draw what's the net force on this thing? You don't have it again, do you? Phoenix, what'd you get?
61.416.
Newtons. Great. But now we still got to find the theta value. And of course, yeah, we could round this guy off. And we only have like 3 sig figs based on the angles. We only had 3 sig figs, so it's approximately 61.4 newtons. But with regard to the angles, remember, we had this vector diagram. We're trying to find theta. Notice the opposite is f net y. The adjacent is f net x. So I'm going to say tan theta is equal to opposite f net y divided by adjacent f net x. And we're trying to get the theta, so theta is equal to tan inverse of f net y was that 35.7961 newtons. F net x was the 49.9067 newtons. The units of newtons cancel out, by the way. I haven't really been talking about that, but they do disappear. Somebody help me out. What's the theta value? Looks like it's going to start with a 3, I think. Just based on the ratio.
35.6.
What do you get?
35.650.
All right. 35.65. Is that the right? Should it be 0 or 1? How's it round?
0.
0? Okay. 0 degrees. And if we're going 3 sig figs on this one, we're going to say that's about 35.7, yeah? Because isn't there like something after that 0? Yeah. So even if there's a 3 out there, notice that that's past the tipping point on the 5. So it's going to go up to 35.7. Okay. And so we can have a little therefore statement for ourselves. I'm going to just do it off to the side. We can say, therefore, the net force is 61.4 newtons. And then we could say east 35.7 degrees north. And as I look at these values, why is it east so many degrees north? Take a look at the vector diagram. It was east 35.7 degrees towards the north. That's how I read that vector diagram, okay? Now it looks like I've given myself like basically no space at all to solve this problem for part B, but when you see what part B is, remember, we're trying to find the acceleration. And isn't F net, didn't we already calculate F net? F net is equal to mass times the acceleration, which means that acceleration is equal to F net over mass. Which doesn't that just mean that we're taking the answer that we had from the previous question and dividing it by the mass? Because remember, the direction of the net force gets contributed to the direction of the acceleration, okay? So we're just going to borrow that direction over anyway. So we sub in our values. Well, F net, should I use the rounded F net value or the unrounded one? Unrounded, 100% of the time. 61.4169 newtons divided by a mass of, it said 4.50 kilograms. I'm just going to write my A there. 61.416 divided by 4.5. Yeah?
13.6482 meters per second squared.
82 meters, nice. Meters per second squared. Anybody want to second that motion? Motion carries, all right. So on 3 sig figs, we say it's 13.6 meters per second squared. And then if I'm going to write my oh shoot, I'm off page. If I'm going to write my therefore statement, I might say, therefore, the acceleration is, you thought I was going to run out of space. But this was a really short little part after I did all that other stuff. The acceleration is 13.6 meters per second squared, and the direction that it accelerates is the same direction at which the net force was pointing. East, 35.7 degrees north. Nice. That's a lot. Now, there is a little comment here in the bottom right-hand corner. When you're drawing free body diagrams, look at that, branding. 4-color clicky pen. You notice that here I am drawing my X and Y components a lot and trying to keep track of things with colors, and it's so quick to be able to switch from color to color without having to put your pen down. I can remember distinctly being in physics and engineering classes, and you can hear when the professor switches from one thing to the next, everybody's color switches because people are trying to color code. I also hear from first-year students now that a lot of them are buying different tablet computers and things like that where they're using a stylus where they can switch over their notes and their color by tapping the colors. And there are even people in my grade 11 and 12 classes over the past few years that have been bringing iPads to class, electronic styluses to class, and taking my notes as PDFs and taking notes in that way just to practice this thing. The nice thing about that is that I'm already supplying the note organizers, which a lot of professors and college instructors will. You guys, if you want to invest that kind of money, and I recognize that it's a serious chunk of change, you can try doing this. I'm okay with you doing that. In fact, I encourage it. I'm not saying go out and drop $1,000. What I'm saying is either drop $3 on a pen, or $1 if you find it at the dollar store, plus tax, or $1,000 on an iPad and you try this stylus thing, okay? Either way, it's going to end up having a good product for you. It'll be nice. But if you do the iPad thing, it might be good practice for you for university, okay? So I'm not like pushing it extra hard, but here you are with a teacher that has notes like this. Maybe it's a good test drive, you know, if you have that kind of advice.